Today is 9-2 day 2. This is actually going to be a 3-day lesson. And so you don't need a new title page. You don't need to update your table of contents. Just go to 9-2 and continue on where you were. Now, I would suggest that you hit pause and you copy down this problem. We're going to have all word problems today, and it's easier to refer back to your notes and look at them if you actually have the entire word problem there. So I would suggest that you hit pause and copy this down. And so if we look at this, we've got an 80% brine solution and a 10%, but we want to create a 50%. So we're going to have to combine the two together, and we want to get a 50% salt to water ratio. So what we're going to do is we're going to set up a table. Our first line is going to be for our 80%. Our second line is going to be for our 10%. And then our last line is going to be mixing it together to make 50%. All right, so what we write out is 80% as a decimal, 10% as a decimal, and 50% as a decimal. Now we need to know, that's our percents. Now we need to know what are the ounces that we have. Well, the only thing that we have for ounces is 16 ounces, that's 10%. So that goes right there. Then we don't know how much of the 80% we need, so we're just going to call that x. So the total solution is going to be 16 plus x. So then we figure out the total on the right-hand column, and we do this by multiplying. So we take 0.8 times x is just 0.8x. 0.1 times 16 is 1.6. And then this one we're multiplying, but when we multiply, we're going to need to distribute it. So let's distribute that through as 8 plus 0.5x. So now what we can use is this last column, and we're going to say the 0.8 plus the 1.6 equals the other one. And so we'll write that out as an algebraic equation. Now that we have an algebraic equation, we can just go ahead and solve this. So I'll subtract 0.5x. And at the same time, just to speed this up a little bit, I'm going to subtract 1.6. And we come up with 0.3x equals 6.4. And then we can divide both sides by 0.3. So x equals 21.3 repeating, or 21 1/3. So now let's make sure that we've answered the question. How much of the solution should be added to create it? Well, we found x, and that's how much we are adding, so that is our final answer. All right, let's go to your left page and try this one on your own. Again, I'm going to just get you started here. Remember to write out your table, listing out the different amounts, 65%, 20%, and 40%. You'll list your percents, you'll list your ounces, and then your total. So try this one on your left page, and then we'll enter it on the clickers. Okay, now this one's a little different. Again, I would suggest copying this problem down into your notes, so go ahead and hit pause so you can copy it down. And sometimes it helps just to draw a diagram. This might not help you at all, but we'll try it. So we've got a river here, or a stream, I guess, and we've got a dock. Let's use that as a point of reference. So she jumps in, she swims for 5 hours in the stream, and it has a current of 1 mile per hour. She leaves her docks and swims upstream for 2 miles, then swims back to the dock. What is her swimming speed in still water? So at first she's going upstream, and so we'll put in this one, and that she went to a distance of 2 miles. And then she had to turn around and go back to the dock. So again, that was 2 miles as well. but we have this current in there. So let's put the current in at 1 mile per hour. Okay, so let's think about this as a distance problem. Distance equals rate times time. We know a distance, and we're supposed to try to figure out the rate. So let's solve this for t. So what I'm going to do is divide both sides by r, and use the formula t equals d over r. So we're going to take our distance, and we're going to divide it by the rate, which we're not really sure what it is yet. So we know that it's 2 miles divided by her rate, but going there, she has a current with her, so we get to add 1 onto it for the current. Well, and then coming back, we get to add in another distance and a rate, but this time she's going against the current, so we have to subtract 1 off. And it equals a total time of 5 hours. Okay, so now that we have that written out, now it is time for us to solve this equation. So we gotta find the least common denominator, which is r plus 1, r minus 1. And we're going to multiply everything by r plus 1, r minus 1. And then cancel. Okay, we're going to have to solve this then. 2r minus 2 plus 2r plus 2. Again, I just distributed that through and distributed that through. Equals. Okay, I'm going to just do my work off to the side here because I have to do some foiling. So I get r squared. Outside is negative 1r. Inside is plus 1r. Last two is negative 1, which is r squared minus 1. But that is multiplied by 5. So 5 times that and 5 times that is 5r squared minus 5. All right, let's see if we can simplify anything down. Over on the left-hand side, we've got 4r, but then the negative 2 and the positive 2 cancels, equals 5r squared minus 5. So I'm going to subtract 4r. Since we have an r squared here, we're going to have it equal to 0 and see if we can solve it. Okay, the quickest way to solve this then would be to see if we can factor it. So let's just try this out quickly. We're going to multiply the 5 times that 5. And then think about a t-chart. So what would add to negative 4 times to 25? The only way to get 25 is 1 and 25 and 5 and 5. So neither of those are going to work. So this is going to be a decimal answer. We cannot factor this. So to be able to find the decimal answer, we have to use the quadratic formula. Negative b plus or minus a square root b squared minus 4ac all over 2a. All right, so let's substitute some things in here. The b is negative 4, a is 5, c is negative 5. So we get then positive 4 plus or minus the square root. Go ahead and type that part in your calculator. Get 116 over 10. So then we can solve that, and we get r equals, the positive form is going to be 1.5, or the negative form is going to be negative 0.7. But in this problem, the negative doesn't make any sense. So our answer is that she's swimming at a rate of 1.5 miles per hour. Okay, go to your left page and see if you can try one of these on your own. And then back to your right page again. I would suggest copying down this problem as well. This is the last problem we're going to do for the day. So to figure this out, we're going to need to take the W name, their rate, plus the U person's rate, and that will give us the combined rate. So the W person can do one job in 4.5 hours, whereas U person can do one job in 3.7 hours. So that would be one job in the rate that is combined. So we'll just put R there. So what we need to do is solve this then. Well, since this is just fractions with regular numbers in them, we can just type that into our calculator and change it to math fraction. So 164 over 333 is what it comes out to be. And then we get 1 over the R. And now we can just do cross multiply and divide. And the rate comes out to be about 2.03. So if they work together, they could complete this job in just a little bit over 2 hours. All right, go to your left page then and try doing one of those on your own. And now this is the end of the second day, but there will be a third day to go along with this, so you do not need to write your summaries yet.